Hello and welcome to the OCR Further Maths videos for Pure Core. This is Calculus 5, Volumes of Revolution and Mean of a Function. And this is video 5.1 Introduction. Okay, so you've worked on the area of under a curve before, and you already know that integration is a limiting process where we sum rectangle areas in order to approximate the area under the curve. In these particular rectangles here, the height of the rectangle is just the value of the function at that point, and the width is delta x. So you can see here we've got 5 rectangles, so we're summing from 1 to 5, the function value at that point with delta x. And as these rectangle widths become smaller, more of them are needed, and the approximation for the area becomes more accurate. So we have increasingly small rectangles, we're summing more of them, and delta x, the width of them, becomes smaller, and we've got a more accurate approximation there. So as we continue this process and we make delta x tend to 0, what we get is the integral between a and b of the function with respect to x, which gives us the area. Now, this process can also be done when we do something called a volume of revolution. And this is where we take our curve and we rotate it 360 degrees, about, in this case, the x-axis. So what we create is a solid that we want to find the volume of. And so instead of summing rectangles, what we're going to look at, you can see here, is summing cylinders. And the next video will look into that in more detail. So the next video is 5.2, rotation about the x.